Okay, so today I promised to you that we would learn about what this little lower box means. The Fruit Loop lab that we did, we said group 1A you got to get 2 around, group 2A you got to get 4 around, group 3A you have to get 6 around, and then essentially every other group on the periodic table wants 8. That's all true, but for phosphorus on down, it has 2 options. Phosphorus can follow the rule of 8, or it can follow the rule of 10. Sulfur on down, and when I mean sulfur on down, it means sulfur and everything below it on its family. So sulfur, selenium, beryllium. Phosphorus on down, so phosphorus, arsenic. Chlorine on down. Chlorine on down would be chlorine, bromine, iodine. So they have 2 options. Chlorine can follow the rule of 14 or the rule of 8. For example, let's do let's do Cl(I)7. So which one goes in the center? Chlorine. How many valence electrons does chlorine have? 7. It's a major group 7. So we do 1, 2, 3. You all have pencils, right? Good, because as soon as I write this down, I'm going to change it. 7. Then I have 7 iodines. Okay? I'm going to put these 7 iodines all around it. So you just try to put them all around. Each chlorine, we said, has 7 valence electrons. And iodine also has 7 valence electrons. That's supposed to be an element. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 4, 5, 6, 7. So every iodine has 7. The chlorine starts with 7. And then here, the iodine has 8. That iodine has 8. That iodine has 8. That iodine has 8. 8, 8, and 8. So 8, 8, 8. And what about the iodine in the center? The iodine in the center has 2, 4, 6, 8, 10, 12, 14. So here's an example of chlorine following the rule of 14. So chlorine has the option of following the rule of 8 or the rule of 14. Chlorine on down. So chlorine, bromine, and iodine all have the option of following the rule of 8 or 14. So how do you know which rule it's going to follow? Okay. This is a rule of thumb here, Kennedy. It's not always the case. But if you're on the inside, usually it's going to follow the higher rule. If you're on the outside, usually it's going to follow the lower rule. Okay, so here we have iodine following the rule of 8. And we have chlorine following the rule of 14. If I reverse this, if this was ICl7, then you'd probably have iodine following the rule of 14 and the chlorines following the rule of 8. Kind of pretty. Looks like a little flower, doesn't it? Who says there's not art in chemistry? In fact, you could use this to like ask your friend to prom. Be like, here's the structure of chlorine heptaiodine. Will you go with me and wear this as a corsage? Really sweet. You can make a corsage out of macrame.
So we're doing that.
I did it. It was a big hit. All right, so let's try another one. Let's do let's try sulfur. Okay, let's just do sulfate. Spice it up a little. We're going to put a charge on there. SO4 to -2. So which element goes in the center there, Marley? Sulfur. Okay. How many valence electrons does it have? What group is it in there, Maria?
6.
Okay, so 1, 2, 3, 4, 5, 6. Got 4 oxygens. 1, 2, 3, 4. And they also have 6 valence electrons. Now it's got a -2 charge there, Elizabeth. When there's a -2 charge, it means you have 2 extra electrons, or as I like to call them, the bonus electrons. You can put them wherever you want. So I have 2 extra electrons, I can put them wherever I want. What I like to do here, Christian, is I like to represent them as stars, just so that I know, like, okay, I've got 2 bonus ones, I'm putting my 2 bonus electrons right there. They didn't come from anywhere. They didn't come from any atom. They just came from the fact it's got a -2 charge. Now, what rule am I going to follow? Sulfur can follow the rule of 8 or the rule of 12. Okay? So, when there is oxygen, carbon, sulfur, or nitrogen, look for both ways. It doesn't mean they'll both be there, but you should look for them. Okay? Doesn't always mean they'll both be there, Allie, but look for both possibilities. So in other words, sulfur can follow the rule of 8 or 12. So let's look for both rules and see if we can do both. So can I get 8 around everything?
Yes.
Yeah. 8, 8, 8, 8, and 8. Because it's got a charge, I must put brackets around it. The line bond structure looks like this. And I put brackets around it because it has a charge. So that probably doesn't look too big of a leap from what we already know. But now let's see if we can get it to do the rule of 12. Okay. Now can oxygen follow the rule of 12? Nitrogen, oxygen, and fluorine can only follow the rule of 8. So oxygen can only follow the rule of 8, but sulfur can do the rule of 8 or 12. We just got the rule of 8. Let's try to find the rule of 12, Rachel. We may not get it, but you should at least see if you can. So, try this again. But this time, I'm going to put in a double bond. Two double bonds. Whoops, those guys don't belong there. And how many are on the sulfur? I've got 2, 4, 6, 8, 10, 12. So I got 12 around the sulfur, 8 around the oxygens. Put brackets around it because it has a -2 charge. Bless you. In our first example, is there oxygen present? Carbon, sulfur, nitrogen. Then there's only going to be one answer. Okay, here chlorine followed the rule of 14. It did not follow the rule of 8. But if you see oxygen, carbon, mostly oxygen, but sometimes carbon, nitrogen, or sulfur, look for the other rule, the other possibility. Okay. Again, it doesn't mean it will be there, but you should at least look for it. The line bond structure looks like this. We've got a double bond here, a double bond there, single bond there, single bond there. The 2- charge. So which one's better? Is this structure better or is that structure better? We go back to this chart. Now I haven't talked much about the bonds. Okay? You have to follow the rule. Try to get the right number of bonds. So sulfur wants 12 electrons and 6 bonds. You must get the 12 electrons, John. Try to get the 6 bonds. If it's following the rule of 8, then the sulfur must have 8 electrons and 2 bonds. Try to get the 2 bonds. Oxygen follows the rule of 8. Try to get the 2 bonds. So let's take a look at the first one. Sulfur's following the rule of 8 here. How many bonds does it have coming off of it? 4. If it's following the rule of 8, how many bonds does it want? 2. So it doesn't have the right number of bonds, so it's not happy. Okay? It's got the right electrons, that's good, but it doesn't have the right bonds. How about the oxygens? They all have the right number of electrons. How many bonds does it have? They all have 1. How many do they want? 2. Any questions so far? Starting to feel like this is a lot being thrown at you. We'll then look at this structure. Here sulfur's following the rule of 12. How many bonds are coming off that sulfur there, Burke? 6. 2, 4, 6. Okay? So 6 bonds. So sulfur has 12 electrons, 6 bonds. So the sulfur's happy. Woo! What about the oxygens? At least these 2.
Very happy.
They've got their 2 bonds. They're happy. These 2 guys, not so much. But we do have 3 atoms that are happy, 2 that aren't. That's better than up here where nobody's got the right number of bonds. So given the choice, this is the better structure. You would rather follow the rule of 12 because at least you have 3 atoms that are happy and only 2 that are sad. Up there, everybody's sad. Now when it comes for a test, you do need to put down both correct options.
When's the test?
Quiz. Not this week?
Not
This is a bad week?
Every single day.
How
Not.
about Saturday? You know, there are some places where they go to school on Saturday. Just a shout out to my Indian friends. Isn't that right? Saturday, half a day, school,
What's the point of that?
so they can catch up with the rest of the world and surpass us. It's kind of like 2 days in practices.
What?
What? So you may have noticed that these 2 double bonds don't have to be there. Those 2 double bonds could have been there, right? In fact, all the options are as follows.
Do you have to do every combination?
Every combination.
I'm gonna wreck it.
You won't wreck it,
Wait, why? Why?
because these are all the possibilities.
It's like the same thing.
So you're
No,
gonna
it's
make
not.
us-
That's different than that.
You're gonna make us do that on the test?
I can't make you do anything in life but pay taxes.
Don't be that guy.
that
No,
what you
I'm
were
not
s-
that guy, but what was it, Ben Franklin? There's only 2 things in life you have to do, and that's die and pay taxes. So,
So to get full credit on the test, you have to do each one.
yep, all possible correct answers. That's all of them, right?
It's like the peas and carrots
Oh,
one
missing
for
one.
straight all over again. How many combinations of peas and carrots can you have if you have 10 total? I hated those so much.
You know, they don't go away. They ask you that on the GRE and the
Forgot one more.
SAT.
Also, the one with the
Do it both on the left side. Five on the left.
and the bottom.
Oh, yeah. Look at that.
And the dumb thing was you had to say like 9 peas and 1 carrot and 9 carrots and 1 pea. Like it's the same thing. That made me very upset.
I always just put down the answer is false. Children don't eat vegetables.
Oh,
So,
that's true too.
Can you go?
so as you probably realize, this takes up a lot of room and space. There must be a better way, Aaron. There must be. So,
Of course. I'm
Um,
just like, just kidding, there's not, I just said that.
that's a double bond. That's a single bond. The double bonds don't have to be in those locations. They can be there, they can be there, they can be there, they can be there, they can be there. What happens in reality is that these double bonds kind of get smeared out over the whole thing. It gets shared over the whole molecule. So it's really not a double bond. It's not a single bond. It's in between, like a 1.5 bond. We call it a resonating bond. And so instead of drawing all 6 structures, you can just draw one, like so.
Where are you growing?
You draw a dashed line to indicate that that double bond is resonating. Because there are 2 resonating double bonds, we have to write under there 2 resonating double bonds. If there is 1 resonating double bond, you don't have to write it. But if there are 2 resonating double bonds, Allison, you have to write down that there are 2 resonating double bonds. Because looking at the picture, there's no way of knowing, Vakua, if there's 1 double bond that's resonating, or if there are 2 or 3, because you can have a situation like you could have a situation like this, where that double bond could be there, or there, or there. So here would be a situation where you would have 1 resonating double bond, okay? If you have 2, then you have to write down that there are 2. Or if you have 3, you have to write down there are 3 resonating double bonds. Now, there are some false prophets out there that will lead you astray about the nature of resonating double bonds. The temptation is to think of it as that the double bond is moving from place to place. That's not true, okay? So if a teacher ever tells you that the double bond is moving, that's not true. It's more like you're taking that 1 double bond and smearing it all over the whole molecule like peanut butter. Not that we ever have peanuts in school. But if we did,
It's okay.
we'd
friend, I know
smear
how to
it
use the-
all over, because that double bond is actually, the double bond is actually in 3 places at once. Okay? That's a resonating double bond. It doesn't have the full strength of a double bond, but it's greater than a single. It's a double bond that's smeared over the whole molecule. Okay, that's the true nature of it. Yep.
What about triple bonds?
Triple bonds, you can have resonating triple bonds. It's not as common. And the only ones that I know of involve carbon. A situation something like this. Where sometimes the triple bond can, wait a minute, I'm missing something here. Where sometimes the triple bond can flip over here. And then you would, draw it something like this. But they're pretty rare. And I didn't completely draw that structure either.
Mr. Mr. Strauss, what would you compare the texture of peanut butter to?
That's a good question.
Because Janine's like never had it. 'cause-
I heard cream cheese, but.
No.
It's like there's nothing.
Cream cheese with stones in it.
Oh, that's great. That's appetizing.
So, any questions? All right. Well,
When we have the video up.
adios and until next time.